Assalamu alaikum. I am Wasif Kareem and I am here to discuss a program of 8051 microcontroller, and the program is to generate a square pulse using 8051 timers. So the square pulse will be like this. Now, as we know, the frequency of crystal oscillator of commonly used 8051 microcontroller is 12 megahertz, and 12 pulses are required for the machine cycle. So each machine cycle is of 1 microsecond of time period. So now we have to, according to question, time period will be calculated like this: 1 millisecond into class roll number, and my class roll number is 35, so it will be 35 millisecond. So graph will be like this: t on and t off both will be equal to 17,500 microsecond. Now we have to deal with four registers: TL0, TH0, Tmod and Tcon if we are using timer 0, and TL0 and TL0 and TH0 are used to set the number of counts it have to count. Now, so as we know, 8051 timer uses up counters. So when registers TL0 and TH0 of timer 0 is set to a particular number, and when timer is started, it up counts from the number set at TL0 and TH0 and counts till the register overflows after FFFF, and overflow flag TF0 is set and count stops. So as we know, TH0 and TL0 are 8-bit registers, so in total it will be 16-bit overall 16-bit. So TH0 and TL0 will be counted, evaluated like this: 2 to the power 16 minus number of counts which we have to count, that is, and it will be evaluated as like this: 48,036 in decimal, and it will be converted into hexadecimal, and it is BBA4. So TH0 will be BB in hexadecimal and TL0 will be A4 in hexadecimal. So now we have to deal with other two registers, that is Tmod and Tcon. So for Tmod register, as we are using, here is Tmod register. So as we are using timer 0, so we don't need to set any bit of timer 1 region, so there is no need to set these bits, so all these bits will be 0. It will be like this. Now in timer 0 region we don't need any interrupt, so gate bit is not required to set, and we are using it as timer, so T bar bit will be also 0, T bar or C bit will be 0. So it will be like this. Now other two bits are for selection of mode, and we know to use 16-bit timer we can use timer mode 1, and it will be like this: for selection of mode 1, M1 should be 0 and M0 should be 1. So overall T mode register would be 0 0 0 0 0 0 0 1 in binary, and in hexadecimal it will be 0 1. Now coming to the next register, that is Tcon register. So in Tcon register the lower 4 bits are for external interrupt, and we don't need any external interrupt, so there is no need to set these, so all these bits will be 0. So we are using timer 0, so no need to set bits of timer 1, so TF1 and TR1 will be also equal to 0. So it will be like this. Now TF0 is overflow flag, and it is automatically set when TH0 overflows after FF. So now it should be set, it should not be set because it will stop the timer, so it should be equal to 0. And if the counting is to be started, TR bit is to be set, so TR0 is required to set, so it is 1 here. So overall Tcon register will be equal to 0001 0000 in binary, and it will be 10 in hexadecimal. So now coming to the program code, suppose we pass the generated square pulse at pin 1.0. So first P1.0 is set for high portion of square pulse. Now this high portion of pulse wave is to be maintained at P1.0 for a period of 17,500 microsecond. Now for this we have to call a subroutine, and I named it as lag. So it is like this. It can be anything like delay, and that means its name can be anything like delay or any appropriate word. Now we have to create subroutine named lag to provide delay of 17,500 microsecond. Now as earlier we have evaluated for which the register TL0, TH0, Tmod and Tcon is to be set. So these numbers are moved to these registers. Now we have to add a jump instruction here so that it waits here until TH0 overflows and TF0 is set. So for this I have this subroutine named hold on, and through this the P1.0 will be high for 17,500 microsecond. But now before returning to the caller, TR0 is needed to be cleared to stop the timer function, and TF0 is also need to be cleared, which was set after overflow in TH0. So it will be like this, and then it is returned to the caller. Now similarly for the low portion of pulse wave, P1.0 is cleared and the delay of 17,500 is provided by calling lag routine like the previous one. Now this program will generate only one cycle of pulse. So to get pulse train we have to add a jump instruction which would infinitely execute these codes, and a continuous pulse train would be generated at pin P1.0. So we have called it SJMP, and the main function will be called infinitely. So this is all about the program to generate square wave of time period 35 millisecond. And if you have any query you can contact me, and thank you for your concentration. Allah Hafiz.